In this video, I'm going to go over some definitions and theorems with perpendicular and angle bisectors and then use them to do a couple of problems. You'll notice a few of the questions, you'll see some similarities to problems we've done in the past, and then we'll finish at the end of this video with a proof. Okay, so let's first talk about the definition of a perpendicular bisector. Okay, so this is a line that intersects a line segment at a right angle. Okay, and then also it divides that segment into two equal parts. So it divides that segment into two equal parts. All right, that is the definition of a perpendicular bisector. Now, one of the nice things about that you'll see when we use this understanding in a question or a problem, because it divides that segment into two equal parts, it passes through the midpoint of that segment. So it's going to pass through the midpoint. So just keep that in the back of your mind when you see a definition, or excuse me, a perpendicular bisector. Okay, now for an angle bisector, all right? So this is a line or ray that divides an angle into two equal parts. So a line or ray that divides an angle into two equal parts. All right, so now when I move into the theorems to use these, I'm going to start with the perpendicular bisector theorem. All right, so this first theorem is essentially something you discovered in the CLT if you were in class today. All right, so this theorem we're going to use states that if a point lies on the perpendicular bisector of a line segment, then it is the same distance from both endpoints of that line segment. Okay, so if a point lies on the perpendicular bisector of a line segment, then it is the same distance from both endpoints of that line segment. Now, I'm hoping this is not a surprise for you again if you were in class. When we proved this, essentially, in our CLT, you practiced different points, and different groups had different points, and they all ended up being the same distance. Okay, so let's do the converse of that. All right, so the converse, we're just going to switch the order here. All right, so we're going to say if a point is equidistant from the endpoints of a line segment, then that point lies on the perpendicular bisector of that line segment. Okay, all right, I know that was a lot of writing, but we're going to be using this information to help us on these next three problems. All right, so just three problems. It's a short practice here because we'll be doing this after we do our test on our congruent triangles. All right, so this first problem, one thing I want to make sure you look at is make sure on your paper, if you haven't already, this is actually line SI and is the perpendicular bisector of segment WM. All right, so the figure looks great. Everything else looks good. Just change those to be SI is the perpendicular bisector of WM. So because that is bisecting it, all right, and it says it's a perpendicular bisector, that is going to make these pieces are going to be the same, right? Because it's bisecting it right down the middle of that segment WM. All right, I'm going to label everything else. SW is 2x. We have SM is 19 minus 5y. WI is x, and then MI is negative 7 plus 14y. So the first equation that I wrote based on this information is I wrote that WI, so segment WI, is the same as IM, right? Because of that perpendicular bisector. So I wrote x equals negative 7 plus 14y. The next one that I wrote is based on the perpendicular bisector theorem here, right? That if a point lies on the perpendicular bisector, so this point is S right up here, then it is going to be the same distance to each of those endpoints. So essentially, I'm saying that this distance should be the same as this distance, all right? So marking that there, I'm able to write another equation, which is 2x equals 19 minus 5y. So this is what we call a system, and it's up to you on how you want to solve this. You can use elimination, you can use substitution. It doesn't say which one you have to use, so ultimately, you can do whatever you would like, all right? What I noticed in the first one that I did was I had x equals, so I'm going to take that and I'm going to substitute that where it says x in my second equation that I wrote. So I'm going to write 2 times negative 7 plus 14y is equal to 19 minus 5y. Distribute the 2, get negative 14 plus 28y equals 19 minus 5y. I'm going to move my minus 14 to the other side, which will give me a positive 14 plus 19 is 33 minus 5y. Move that minus 5y over with addition, and you get 33y equals 33. So y equals 1. Now, like we've been doing with these solving systems in that last unit, make sure you plug this back in to either of your equations to find x. I'm going to use that second equation, excuse me, the first one. X equals negative 7 plus 14y. Plug in my y is 1. So x equals negative 7 plus 14, so x equals 7. All right, it does ask me after I find x and y to find the values, the distances of SW and WI. All right, and I can find all of these if you'd like. It won't take very long. So this one's going to be 2 times 7, so that's 14 for SW. WI is just x, which is 7. That means this one is 7. And this one over here is also 14. Checking my work. Let's see, 19 minus 5 is 14. Negative 7 plus 14 gives me 7. So that all checks out. So that's the first one using some information that we kind of formalized in the notes above it. Let's go to number 2. Okay, another thing I want you to correct is I'm actually going to use the ordered pairs that are in the graph here. So I'm going to change this. Point A is going to be negative 2, negative 7. All right, so this is going to be point A. And then point B is going to be that other one, which is 6, 5. So you can go ahead and cross out those two and get the correct ones here. So this is point B up here. And we're trying to find the equation of a perpendicular bisector. Remember, a perpendicular bisector, obviously it's going to be perpendicular to this line. All right, so that gives us some information that we've used in previous units. And also, this is kind of the other thing we're going to use from the way back the first unit, is if it's a perpendicular bisector, it goes through the midpoint. So one of the things that we need to make sure your brain is thinking here is we should be thinking we need to find the midpoint. So going back to your days in the unit 1, finding the midpoint of AB means we're going to do x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. So that's going to be negative 2 plus, one second, there we go, plus 6 over 2. And then we have negative 7 plus 5 over 2. So that midpoint is going to be, That's going to be 2, and then that's going to be -1. So that is my midpoint. So if I were to plot that right now, 2, -1 is right there. All right, which shouldn't surprise you, right? That intersects that line, or our bisector is going to intersect it, that segment AB at that point. All right, so now we need to find the slope of AB, all right, using our slope formula, the change in y over the change in x. And this is important because once I find this slope of AB, the slope of the perpendicular bisector that I'm trying to find will have opposite reciprocal slope to this one, okay? So this is going to be our 5 minus -7, so that's the change in the y, over 6 minus -2. 5 minus a -7 is really 5 plus 7, which is 12. 6 minus a -2 is really 6 plus 2, which is 8. Both of those can be divided by 4, so you get 3 over 2. Again, that is the slope of AB. The slope of the perpendicular bisector, so slope of perpendicular bisector is going to be -2/3, right? Opposite reciprocal. So that's the slope that I'm using. So this is important here. And I also am going to be using this point, the midpoint. So once I have a point, I have a slope, I'm ready to use point slope form. All right, which is y minus y sub 1 equals m times x minus x sub 1. So plugging in, I have y minus a -1, which is y plus 1, equals my slope of -2/3 times x minus 2. I'm going to distribute that -2/3, so you get -2/3 x, and then it's going to be plus 4/3. So my answer here, when I move that 1 over with subtraction, it's going to be -2/3 x, and then 4/3 minus 1, which is really 3/3. 4/3 minus 3/3 is going to be plus 1/3. All right, so this is the equation in slope-intercept form of my perpendicular bisector. It doesn't say I need to graph it, but I'm going to go ahead and graph it. I'm going to go up to left 3 from this midpoint. Do it again. Then down to right 3. And if I make this line here, I'm hoping you'll see this is going to be perpendicular to my line AB and creates that right angle. We'll go with that. All right, so there's the perpendicular bisector of segment AB. All right, a lot of stuff that we've been using in the last, since the beginning of the school year. Okay, let's do our last one, which is a 2-column proof. All right, so I'm going to make my 2 columns here. So I've got my statements, got my reasons or justifications. Starting with my givens, I have WX, that segment bisects angle ZXY, that is given. Then I have segment ZX is congruent to segment YX. I'm going to go ahead and mark that on my figure here. So ZX right here and YX are going to be congruent. Now, when I wrote that first given, segment WX bisects angle ZXY. So what that's going to do, because that is an angle bisector, is that is going to create 2 angles that are congruent. So this angle here is going to be congruent to that angle there. So ZXV is going to be congruent to YXV. So I'm going to go ahead and write that down. Angle ZXV is congruent to angle YXV. And this is the definition of an angle bisector. Okay, now what you probably notice, hopefully you notice from doing lots of these, is that these 2 triangles, which I'm trying to prove, right? Always check out that proof. I'm trying to prove ZXV and YXV are going to be congruent, and they actually share a segment, a side length. They share this one right here, which is XV. So using the reflexive property, I can say that those are congruent. So the reflexive property of congruence. Okay, and then finally, after I have that, I have everything I need to prove these triangles are congruent. So I'm going to say triangle ZXV is congruent to triangle YXV, and that would be side, angle, side. All right, so hopefully you see that this is using new things, but also using lots of things we've used since pretty much every unit since the beginning of the school year. But don't forget to come see me if you have any questions, and good luck on the homework.